Professor Belfrost's computer science class is back!
Hi, welcome back. And here's Professor Belfrost's class on computer science. And today we are going to explore another concept on computer science, continue our last lesson. And if we are already ready for today's episode, then let's go. Great, you still follow, right? Okay, so in the previous video, we have explained about grade level 0, grade level 1, and grade level 2. And today we'll continue from grade level 3. Grade level 3 is also similar to grade level 2 because it makes use of parallel access technique, but there is some slight difference in grade level 3. That grade level 3 only requires a single redundant disk no matter how large the disk array, not like grade level 2. And yeah, grade 3 also employs parallel access, the data distributed in small strips. Okay, and instead of an error correcting code, a simple parity bit is computed for the set of individual bits in the same position on all the data disks. So here is the mechanism for the redundancy. So for doing data reconstruction is simple. So here's the way this is you are given example for uh, 5 drives, okay? And suppose that you have x1 drive field, then you can do the way as shown. And thus, the contents of each strip of data can be regenerated from the contents of the corresponding strips on the remaining disks in the RAID. So in the event of this failure, the of data is still available in what is referred to a reduced mode because it makes use of exclusive or calculation. How about the performance? The performance is also quite great because the data is structured in a very small strip that you can achieve a very high data transfer rate. Okay, so yeah, for large transfer data performance improvement is especially noticeable, but for transaction-oriented performance environment, the performance is suffers for this grade level 3. Now grade level 4. So from 4 to 6, they will make use of an independent access technique. And with an independent access array, each member disk will operate independently, so that separate IO requests that can be satisfied in a parallel fashion. Independent access arrays are more suitable for applications that require high IO request rates and are relatively less suited for applications that require high data transfer rate. And also, yeah, the same thing for all the RAID is that the data striping is also used. In the case of RAID 4 to 6, and the strips are relatively large, not as RAID level 2 and RAID level 3. With RAID 4, the bit-by-bit parity strips calculated across the corresponding strips on each data disk, and then the parity bits are stored in the corresponding strip on the parity disk. Okay, so this involves a write penalty when an I write request on a small size is performed. Okay, so we have what called a write penalty. So every time the write occurs, the array management software must update not only the user data but also the corresponding parity bit. Okay, so in the case of a larger size IO write that involves strips on all these drives, the parity is easily computed by calculation of using only the new data bits. And thus the parity drives can be updated in parallel with the data drives, and there are no extra reads or writes operation. Okay, but every write operation must involve the parity disk, and therefore this can be a bottleneck. So this is a problem for RAID level 4. Now we have RAID level 5. So RAID 5 is actually organized in a similar fashion to the RAID 4, but the difference is that RAID 5 distributes the parity strips across all disks. And this is what called typical allocation with a round robin scheme. Okay, and this can avoid the potential I/O bottleneck that found in the RAID 4. Then we have RAID level 6. With RAID level 6, the two different parity calculations are carried out and stored in separate blocks of different disks. Okay, So a RAID level 6 array whose user data request NDs actually consists of n plus 2 disks. The advantage of this RAID level 6 that it provides extremely high data availability. Queries will have to fail within the MTTR or mean time to repair interval to cause the data to be lost. Okay. So yeah, with RAID 5 and RAID 6, the RAID performance is comparable. Let's see the table 6.4 for the comparison of the advantages, disadvantages, and application of each type of RAID that we have discussed so far. Maybe I'll not write this one by one to you because they are quite long. I will need to pay attention on yourself and respect yourself. Okay, we have 0, 1, 2, 3, 4, 5, 6. Actually, there are more because actually in some textbook it will show you the combination of like 0 and 1, 1 and 0, 5 and 6 together. But maybe in this book there are no explanation like that. Okay, just keep it aside. Okay, because maybe you'll find maybe I'll also create another video in the future about specifically the rate things. Okay, let's see. Now we'll dive into discussion on optical memory. So yeah, one of the most successful consumer products of all time is called compact disc. Okay, so CD is basically a non-erasable disc that can store more than 60 minutes of audio information on one side. Okay, let's see table 6.5 for more information. Okay, so we have some optical disc products. We have CD, we have CD-ROM, we have CD-R. Okay, so R is for read, W for write. Okay, CD-R, CD-RW. Okay, R is for read and recordable. Okay, we have also DVD, the digital versatile disc. We have DVD-R, we have DVD-RW, we have Blu-ray DVD. Okay, maybe most of now we don't use CD anymore. Okay, we'll start from compact disc or CD. So first type is CD-ROM. So both the audio CD and the CD-ROM share similar technology, and the main difference is that only the players are more rock and have error correction devices to ensure that the data are properly transferred from disk to computer. They are both made in the same way that this is for a resin, such as polycarbonate, and then the digital recorded information is imprinted as a series of microscopic pits on the surface of the polycarbonate. It's done by using laser. The information is retrieved from a CD or a CD-ROM by a low-powered laser housed in an optical display or a drive unit. Okay. Specifically, if the laser beam falls on a pit which have a somewhat rough surface, the light scatters and a low intensity is reflected back to the source, and the areas between the pits are called land, and the land is a smooth surface which reflects back at a higher intensity, and the change between the pits and lands is detected by the photosensors and then converted into a digital signal. Okay. Okay, we have CAV, we now have CLV. They are actually two kind of technology. CAV we have discussed it before, right? So data on CD-ROM are organized as a sequence of blocks. So we have following fields. We have sync, we have header, we have data, we have auxiliary. So CD-ROM has two advantages. That is, the optical disc together with the information stored on it can be mass replicated inexpensively, unlike a magnetic disc. And second is that the optical disc is removable, allowing the disc itself to be used for archival storage. But there's a disadvantage, which is it only read only and cannot be updated, and it has an access time that much longer than of a magnetic disk drive. Yeah, that's the two disadvantages of the CD-ROM. Now we are looking for CD-R. Okay, this is only used for application on only one or small number of copies of data is needed. Okay, so yeah, the CD-ROM media is similar to but not identical to that of CD and CD-ROM. Okay, for a CDR, then the medium includes a dye layer, and the dye is used to change reflectivity and activated by a high intensity laser. Now, CD are rewritable. Okay, uh, okay, this one. The only pure optical approach that has been proved effective is phase change. And the phase change is use a method that has two significantly different reflectiveness in two different phase states. We have a amorphous state, and also we have a crystalline state here. The primary disadvantage with this is that the mirror eventually and permanently loses its desirable properties. Okay, and it can only be used for about 500,000 to 1 million, 1 billion or million erase cycles. Okay, and the CD-RW has obvious advantage over the CD-SDR that can be rewritten and thus used as true secondary storage. Now we have DVD. So yeah, the DVD has replaced the video tape used in VCRs, and yeah, has also replaced the CD-ROM in personal computer and servers. So yeah, for DVD, here's the structure. Okay, you can see the difference between the CD-ROM and the DVD-ROM, right? So yeah, the DVD's greater capacity relative to CD-ROMs is due to three differences from CDs. Okay. First, bits are packed more closely on a DVD. Second, the DVD employs a second layer of pits and lens on top of the first layer. Okay. And a dual layer DVD has a reflective layer on the top of the reflective layer, and by adjusting the focus and the lens of the DVD drives can read each layer separately. And a DVD-ROM can be two-sided, whereas the are recorded on only one side on CD. Also, as with CD, the DVDs will come in writable as well as the read-only versions. Then we have high definition optical disc. For high definition optical disc is used to store high definition videos and to provide significantly greater storage capacity compared to the DVDs. Okay. It's achieved by using a laser with a solar wavelength in the blue-violet range. So there are two competing these formats that technologies initially competed. Actually, yeah, it's been passed over time. This is HD DVD and Blu-ray DVD. Okay, so the Blu-ray scheme ultimately achieved market dominance. Now we'll discuss about yeah, so we still have time. Magnetic tape. So tape system. Okay, actually use the same reading and recording techniques as the disc system. And the media here is flexible polyester tape coated with a magnetizable materials. Okay, so data on the tape are structured as a number of parallel tracks running lengthwise. An earlier tape system typically used 9 tracks, and this made it possible to store data one byte at a time with an additional parity bit as a 9 track. The recording of data in this form is referred to as parallel recording, and most modern systems instead of use serial recording, which the data are laid out as a sequence of bits along each track and is done with magnetic disc. So as with these, then there are read and written in contiguous blocks called physical records on a tape. And blocks on tape are separated by gaps referred to as inter-record gaps. We also have typical recording techniques called serpentine recording, where data are being recorded and the first of the bits recording is recorded along the whole length of tape. And when the end of tape is reached, then the heads are repositioned and record a new track, and the tape is again recorded on its whole length, and this time is in the opposite direction. So it goes back and forth. And this is the increased speed actually. A tape drive is a sequential access device. Okay, so if the tape head is positioned at record 1, then to read record n is necessary to write physical record 1 through n minus 1 once a time. If the head is currently positioned beyond the desired record, it is necessary to rewind tape of a certain distance and being reading forward. And in contrast to tape, the disk drive is referred to direct access device. It didn't read all the sectors on this sequential to get the desired one, and it must only wait for the intervening sectors within one thread and can make sure successive access to any thread. Okay, so the dominant tape technology is LTO. Okay, we have done with this chapter actually. Let's see if there are any important things that need to be explained. Okay, actually, yeah, because we have done with the explanation external memory, they will continue to discuss about bus interconnection. Okay, so bus interconnection actually another part of computer's component. So a bus is a communication pathway connecting two or more devices. The key characteristic of bus that it's share. It is a shared transmission medium that multiple devices can connect to the bus, and a signal transmitted by any one device is available for reception by all other devices attached to the bus. And if two devices transmit during the same time, then the signal will overlap and become global, and only one can successfully transmit. So typically, a bus consists of multiple communication paths and line, and each line is capable of transmitting signals representing by and binary 1 and binary 0. Okay, and computer systems contain a number of different buses that provide pathways between components at various levels of the computer system hierarchy. And bus that connect major computer components is called a system bus. Let's say bus structure. We have control lines, address lines, and data lines. The three, all of them are buses. Okay, so a system bus consists of typically from about 50 to hundreds of separate lines. Okay, and each line is actually assigned a particular meaning or function. Okay, and yeah, any bus the lines can be classified into three functional groups: as data, which are data, address, and control lines. The data lines are responsible for moving data among system modules. Okay, so we have what called data bus as a collective. The data bus may consist of 32, 64, 128, or even more separate lines. Okay, and the number of lines we refer to as the width of the data bus. The width of the data bus will be the main factor in determining overall system performance. Next, we have address line, which is used to designate the source or destination of the data on the data bus. Okay, so the width of the address bus determines the maximum possible memory capacity of the system. Also, the address lines are generally also used to address the I/O ports. Next, we have control lines. They are used to control the access to and use of the data and address lines. And because the data and address are shared by all the components, then there must be a means of controlling the use. So control signal used to transmit both command and time information among the system modules. So yeah, the typical control lines include memory write, memory read, IO write, IO read, transfer acknowledge, bus request, bus grant, interrupt request, interrupt acknowledge, lock, and reset. And the operation of the bus is as follows. So if one module wishes to send data to another, then it must actually do two things. The first is to obtain the use of the bus. The second is that to transfer data via the bus. And if one module wishes to request data from another module, then it must first obtain the use of the bus. The second, transfer a request to the other module over the appropriate control and address line, and then it wait for that second module to send the data. Okay. And physically, that the system bus actually a number of parallel electrical conductors, and in classic bus arrangement, then the conductors are metal lines etched in a card or board. Okay, the board is actually PCB. Okay. Okay, and then we have something called MB or multiple bus hierarchies. So if a great number of devices are connected to the bus, then performance will suffer because of two main causes. First is that the more devices attached to the bus, then the greater the bus length, and hence the greater the propagation delay. The second is that the bus may become a bottleneck as the aggregate data transfer demand approaches the capacity of the bus. And accordingly, the most computer systems use multiple bus. There's layout hierarchy. So there's a local bus that connects the process to a case memory and that may support one or more local bus. And a case memory controller connects the case not only the local bus but to a system bus to which are attached all of the main memory modules. Okay, hence the main memory can be moved off the local bus onto a system bus, and in this way the I/O transfer to and from the memory across the system bus do not interfere with the processor activity. Okay, and it's possible to connect I/O controller directly onto the system bus, and a more efficient solution is to make use of one or more expansion buses for this purpose. They can reverse data transfer between the system bus and the I/O controllers on the expansion bus. Okay, you can see this is a traditional bus architecture. There we have high performance architecture. Yeah, maybe I think that's for this lesson. We'll continue on explaining about a bus in the next video. Yeah. So here's a little quote for you today. So Winston Churchill said, "Success is not final, and failure is not fatal. It is the courage to continue that counts." And that's all our lesson for today. Thanks for watching. And here's your to-do list. So please subscribe, give a like, comment, and share this video to your friend. I'll be back on every Monday on the same class in computer science. And don't forget to visit our website at https science with xyz.unux.com. Keep watching and be thoughtful. Goodbye. See you on the next episode.